Welcome to today's lesson. Today we are going to learn about the determination of the area of sectors and composite figures. You can remember that in our last lesson we learned about how to determine the area of a circle, and we realized that a circle has a center and a radius r. So we realized that to calculate the area of a circle, we use the formula pi r squared. Pi r squared. What if today we cut out a part of the circle? Let's see what we get if we try to cut out a part of the circle. So if we cut out a part of the circle in this way, you realize that we remained with a larger part of the circle and a smaller one. And we are not just cutting any part of the circle, but we are cutting along the radius. What do we have? We'll have a shape of this nature, and this one. So you realize that we have two shapes formed by cutting a circle. If we cut a circle along the radius from the center of the circle, what we will have is what we are referring to as the sector of a circle. So then this is a sector, a smaller sector cut out from the circle. And this is also another sector, but this one is larger than the first one. Both of them, we call them sectors. What then is a sector? A sector is formed by dividing a circle with two radii. A sector is formed by dividing a circle with two radii. What does that mean? It means that a sector must have two radii, meaning you are supposed to cut it right from the center and touching the circumference. The sector must also contain an angle inside that sector, and it must also contain an arc. What do you mean? Let's look at examples of the sectors. Let's look at the examples of different sectors. If we have a circle and cut it along this line, which is the diameter, then what we'll have will be a sector of this nature. And you realize that this one, because it is along the diameter, then it will form a semicircle. So the result will have a sector which has a shape of a semicircle. If we cut along these lines, then we'll have a quadrant. In our last lesson, we said a quarter of a circle is called a quadrant. Then if we have 45 degrees, we measure 45 degrees and then we cut out that part of the circle, then the result will have a sector of this shape. If we cut out a sector with an angle of 220 degrees, then this is what we'll have. So then, what does it mean? A sector has an angle. There is an angle inside the sector. Any angle of the sector, any angle inside the sector, if we cut it out, then we'll have a part of a circle that we call a sector with an angle inside that we can now call it theta to refer to any angle. Then this sector also has two radii. We have said a sector must have two radii, and it is originating from the center of the circle. We have said that the sector also has an arc, the part of the circumference of the circle. So if we cut a part of the circle with two radii, it has an angle at the center. It is originating from the center of the circle and has an arc. That forms what we call a sector. How do we determine the area of a sector? Let's try to understand how to calculate the area of a sector. And the area of a sector is determined by calculating a fraction of the area of a circle with the same radius. Because we are getting a sector from the circle, what we need to do as we are calculating the area of a sector is to find the fraction of the sector that has been cut out from the main circle. Because the same circle here has the same radius, only that the sector is a fraction of the circle. A sector is a fraction of a circle. So to find the area of a sector, you calculate the fraction of that sector of that circle, and that will give you the area. Let's look at some examples. So we have said that a sector has an angle inside it. So the first thing that you are supposed to understand when you are calculating the area of the sector is to find out what is the angle inside that sector. If the angle of the sector, as we have seen from our examples, is 180 degrees, 180 degrees, If this, remember, one revolution is 180, so if we cut a half of the circle, a revolution is 360, and if we cut a half of the circle, then what we'll have is 180 degrees inside this sector. So if it is 180 degrees and the whole revolution is 360 degrees, then what is the fraction of the area of that circle? We say 180 degrees over 360, which is for the whole circle. If we simplify, then (18) goes into 36 two times. So what do we have? A half. Then what will be the area rule? We said the area of a circle is pi r squared. A complete circle, you calculate its area by using the formula pi r squared. But because this is a part of the circle that is a half, then the fraction is a half, then we multiply the area of that circle by a half. What if the area inside a sector is 90 degrees? This is a sector that has been cut out and it has an angle of 90 degrees. This is the angle we are talking about, 90 degrees. What fraction of the circle is this sector? To get the fraction of the circle, we look at the angle inside the sector, divide by 360 degrees. 360 degrees and revolution. What fraction does it make? 0 and 0 cancels. 9 goes into 36 4 times. What fraction do we have? A quarter. What will be the area or the rule of calculating the area? Then it is a quarter of the circle, which is 4 a quarter pi r squared. What if the angle inside the sector that has been cut out is 45 degrees? 45 degrees is a half of 90 degree sector. So we will cut it along. That is 45 degrees. We have a sector with an angle inside of 45 degrees. What fraction of the circle will that sector make? Again, we say 45 degrees over 360 degrees. Then we simplify. (45) goes into 368 times. So the fraction of the circle that has a 45 degrees angle is 1 over 8. So what is the area rule? 1 over 8 pi r squared. The same case with if we have another one of 30 degrees. 30 degrees, then what do we do? 30. Then you simplify. Simplify. 0 and 0 cancels out. 3. This is 12. The fraction of the sector is 1 over 12 of the circle. Then if we are supposed to calculate the area of this sector, we say 1 over 12 pi r squared. Now, what have we realized from these examples? If you have a sector with an angle inside, any angle, let's call it theta, we have a sector with an angle theta, and you are told to calculate the area of this sector. So the first thing we have said is to determine the fraction of that sector, the fraction of a circle that makes that sector. How do you determine the fraction of the sector? We say the angle inside the sector divide by 3. (360°). This will give us the fraction of the fraction that makes the sector. And then what will then be the area of that sector? Theta over 360° pi r squared. So the first thing when you're determining the area of a sector is that you must know the angle at the center or the angle inside the sector, because the angle will be able to give you the fraction that that sector makes. And as we have said, determining the area of a sector, we calculate it from a fraction of the whole circle. So that is the rule for calculating the area of a sector. Theta over 360 pi r squared. Let's see if we can be able to find the fractions that these sectors make of a circle. So let's try and determine the fractions of a circle that these sectors make. What fraction of a circle in its simplest form is shown by these sectors? So again, we said to be able to determine the fraction, we look at the angle at the center, we divide by 360 degrees. Let's look at the first one. So what is the angle at the center inside the sector? This is 90 degrees. This is right angle, 90 degrees. So we will say 90 degrees over 360 degrees. And remember, we are told to leave it in the simplest form. So 0 and 0 cancels out. We have 9 into 36. We have 4. That will be a quarter. That sector is a quarter of the circle. What about this one? This sector here is subtended by 60 degrees. What fraction is it? Again, we say the angle at the center, or the angle inside the sector, divided by 360. And again, we remember to simplify. This one cancels out. 6 goes into 36 6 times. The fraction of a circle. This one is 1/6 of a whole circle. Again here, we look at the angle inside the sector, that is 120 degrees. Then we divide by 360 degrees. Then we simplify. 0 and 0 again cancels out. Sorry. 12 goes into 36 3 times. So what do we have? This forms a third of the circle. So this, you should know how to determine the fraction of a circle, because we have said the area of a sector is determined by calculating a fraction of the area of a circle. Very important. Now that we know how to determine the fraction of the circle that a sector forms, then we can now be able to calculate the area of a sector. So let's look at this sector. You are told to find the area of these sectors to 2 decimal places. We are given a sector with 60 degrees inside that sector and radius 13 millimeters. So we have said that the first thing that you need to do is to determine the fraction that that sector makes of a circle. And how do we do that? We said we subdivide the angle inside the sector with 360 degrees to get the fraction. Then multiplied by pi r squared. Then we will have 60 over 360 degrees times 22/7, which is our pi, times radius, which is 13, and the radius is squared. So that is 13 times 13. We are substituting in the formula. Theta over 360 pi r squared. So this is our theta, the 60 degrees, over 360 pi r squared. If we simplify this correctly, so if we calculate this correctly, then we'll have 88.5238.095. That is if we are using the calculator. But we remember that you are told to give your answer to 2 decimal places. So that will give us square millimeters. Remember we said the units of area is square units. So because this was millimeters, the answer will be square millimeters. To 2 decimal places, then the answer will be 88.52 square millimeters. So let's look at this sector. Remember we said that a sector can be a smaller sector or a larger sector. So if we cut out, the smaller sector is not required here, we have the larger section, then the area or the angle at the center is 270 degrees. Then we substitute in our formula, calculating the area of this sector. So what is our theta? Our pi, 22/7. Our radius is 5.1. Zero, let us simplify. 0 and 0 cancels out. By 9, we have 3. By 9, we have 4. By 2, we have 2. By 2, 11. Then if we calculate that, so you'll have 61.309285.7. But we are asked to give an answer to 2 decimal places. Because 9 is past 5, then we carry 1 here. And we have 61.31. So that is how we calculate the area of a sector. We use the formula theta over 360 pi r squared. So the first thing you do, identify the angle inside the center, inside the sector. You divide by 360 degrees times pi r squared. Now, let's proceed and look at how to calculate the area of composite figures. Last lesson, we said composite figures comprise of 2 or more basic shapes. Example, that's an example of a composite figure. Because if you look at it keenly, you realize that this figure here is made up of 2 basic shapes. This is a rectangle, and this is a semicircle. So for you to be able to calculate the area of this composite figure, you need to calculate the area of rectangle, then you add to the area of a semicircle. The area of a semicircle. So generally, we normally calculate the area of a composite figure by either adding or subtracting the areas of the basic shapes. this is another example of a composite figure. Realize that it has a square outside, and then we have at the center, we have a circle. So if we are told to calculate the area of the shaded part, what do? You realize that we calculate the area of the square, then calculate the area of the circle and subtract. So we are saying the area of a composite figure is obtained by adding or subtracting the areas of more basic shapes, adding or subtracting. So this we obtain the area of this figure by adding the area of the basic shapes. We obtain the area of this shaded part by subtracting the area of the basic shapes. So this is a figure, a composite figure. You are told to find the area of this composite shape. So the first thing that you need to understand, or you need to find out when you ask to find the area of a composite figure, is to identify the basic shapes that make up that composite figure. So which are the basic shapes? You realize first of all that this is a rectangle because the sides are not equal, yet they are parallel. And we have right angle angles where they meet. So this is a rectangle. We have a rectangle. Then what about this part here? If we join the dots, you realize that this part that has been cut out sorry, from this shape is a sector. You realize it is a sector. A sector has been cut out from this composite figure. So how do we calculate the area of this side? The dotted side is not required. We need this. The area of this figure. Are we going to add the areas of the basic shapes, or are we going to subtract? We normally subtract if a part of that composite figure is not required. So you realize that this part is not required, then we are going to subtract. So first of all, let's find out the area of the rectangle. And we said in our last lesson that area of a rectangle is calculated by length times base. Length times base. What is our length? 20 millimeters times our base, 10 millimeters. What does that give us? 200 square millimeters. Let us now find the area of the sector. We have just said the formula of calculating the area of a sector is theta over 360 pi r squared. If we substitute our values in this formula, we have what is our radius? What is the radius of this sector? What do you realize? You realize that the radius of the sector is the base of the rectangle, right? Yes. 10 millimeters. If we simplify this, then we'll have so if we calculate it correctly, then we'll have 78.57 square millimeters. This is the area of the sector. The area of the rectangle is 200 millimeters. And we have said the area of the shaded part is got by subtracting the area of the sector. That is length times base, which is the rectangle, minus theta over 360 pi r squared for the sector. And that will give us 121.43 square millimeters. So this is an example of a sector which the basic shapes, area of the basic shapes are subtracted. Find the area of this composite figure. Let us find the area of this composite figure. Do we add? So the first thing that we are saying we are supposed to do, identify the basic shapes that make up the composite figure. You realize that there are two basic shapes here. We have a triangle, and then we have a semicircle. Good. We have a semicircle. So how do we find the area? We need all of this. It is all shaded. So how do you find the area of this figure? We calculate the area of a triangle, then the area of the semicircle, and add. That will be our area. So let us calculate the area of the triangle. What was the formula of calculating the area of the triangle? If you can remember, we said the area of the triangle is calculated by the formula half base times the height. A half base times the height. And we said the height is perpendicular to the base. That is the height of this triangle. So we are given the height is how many centimeters? 10. Let us substitute in our formula. A half times 20, which is the base. You realize that this is a common length. It is the base of the triangle as well as it is the diameter of the semicircle. So they share. It's a common length. So we say I have 20, which is the base, times the height, which is 10. And that will give us 100 square centimeters. That is for the triangle. Let's calculate the area of the semicircle. You remember the formula of calculating the area of a semicircle? Because we said it is cutting the circle into 2 equal parts. What angle is subtended by a semicircle? 180. So the area of the sector, we say 180 degrees, because this is a semicircle, 180 degrees divided by 360 times pi r squared. So our pi is 22/7. Our radius is 10. Where do we get 10? This is not the 10 we are talking about. The 10 we are talking about is, we are told from this point to this point is 20. That is the diameter of the circle, 20 centimeters. But the formula of area is pi r squared. We need to find the radius. How do you find the radius? We divide the diameter by 2. If we calculate that correctly, then we have 157.142 square centimeters. This is the area of the sector. This is the area of the triangle. We said to calculate the area of the sector, we add the composite figures. And that will give us 257.14 square centimeters. And that is the area of that composite figure. Let's look at this other example. Find the area of the shaded region. We have a circle, a bigger circle, measuring 5 millimeters in radius. Then we have a circle, a small circle inside that circle that is measuring 2 millimeters. We are told from this point to that point is 2 millimeters. That means that is the diameter. Let's find the area of the shaded figure, the shaded region. How do you find the area of the shaded region? You realize that we will find the area of the larger circle, then we find the area of the smaller circle and subtract. We subtract. If this is A, area, will it be A minus B? A minus B. So let us find the area of A, the larger circle. Area, we will get it by using the formula pi r squared, because it is a complete circle. This is not a sector, it is a complete circle. If we calculate this, we get 78.57 square millimeters. Let us calculate the area of the smaller circle. Again, we still use the formula, because again, it is a smaller circle, but it is a complete circle. What is the radius of this circle? We are given the diameter, which is 2. How do you get the radius? Divide the diameter by 2. So we say 2 divided by 2, 1. So the area of the smaller circle is 3.1 square millimeters. Then how do you get the area of the shaded region? We subtract the area of the two circles. And that will give us 75.43 square millimeters. Again, remember the units are square. So this is another example of a composite figure. We are looking at different examples of composite figures and how to calculate their area. Let's look at this example here. So the first thing we have said you are supposed to ask yourself is, which basic shapes make the composite figure? So if we look at this keenly, you realize that there is also a larger semicircle, and inside there is a smaller semicircle. We are told to calculate the area of the shaded region. How do you calculate the area of that shaded region? the larger semicircle. We will calculate the area of the larger semicircle, then subtract the area of a smaller semicircle. So area will be got by A covers the whole of this part without removing region B. Then now B is the one that has been carved out. So let us see how to find the area of region A. We need to find out the radius. So we are told the radius of the larger circle is 3 centimeters from here to here. 3 centimeters. And then because this is a semicircle, what fraction of the circle does a semicircle make? We said it is 180 degrees. If it is simplified, it will give us a half. If we do that, calculate that one correctly, then it will give us (99/7). That is the area of the whole region A. Area of B, this semicircle inside the smaller semicircle with a radius of 1 centimeter. It's still a semicircle, so it is a half, or 180 degrees divided by 360, which you have realized that it will make a half. So I'm just writing a half to mean 180 degrees over 360. Our radius for the smaller semicircle is 1. So we say 1 times 1. And that will give us 11/7. We have said area, we calculate the area of a larger circle, the whole of this region. We got 99/7. The area of the smaller semicircle is 11/7. That will give us 12.57 square centimeters. So you need to find out whether you are subtracting or you are adding the shapes that make up the composite figure. Let us look at this other one. So you asked to find the area of the shape in terms of pi. What is the area of this shape? Let's look at this shape. What does this shape make? So we have said the first thing, when you're dealing with composite figures, you identify the basic shapes. So what are the basic shapes? And sometimes you need to connect the dotted lines or introduce dotted lines. And see what it will form. So if we connect these points here, we realize that at the center, we have a square. How do you know it is a square? Because here, we are told the radius. You realize this is a sector which has a radius, and the radius here is 3 centimeters. So you are told this is equal to this, and also equal to this, the radius of this other sector. Meaning, this is 3 centimeters also. This is 3 centimeters. This is 3 centimeters. So if this is a sector, then we said a sector is divided by 2 radii. So this is also a radius, which is 3 centimeters. This is a radius of 3. This is also radius, because this is the sector. This will also be 3 centimeters, because this is also the radius of this sector. And this will also be 3 centimeters, because it is a radius of this sector. So then you realize that the figure at the center is a square. So how do you find the area of this composite figure? So we realize that it is made up of 4 sectors which are equal, and also a square at the middle. So we find the area of the 4 sectors, or we calculate the area of one sector multiplied by 4 because they are all equal. Then we calculate the area of the square and add to give us the area of that composite figure. So let's start by calculating the area of the square. I'm putting AS to represent square. And square, we said it is length squared. What is our length of the square? 3 by 3. And that will be 9 square centimeters. 9 square centimeters. Let's then find the area of the sectors. Remember, we are told to find the area in terms of pi. That means we will leave it. We will not substitute pi. We will just leave it at that. So 90 divided by 360, you realize it is. The area of the sector, the area of one sector, that is the area of one sector, is 9 over 4 pi. 9 over 4 pi. But remember, we have how many sectors? 4, which are equal. So instead of calculating the area of each sector, because they are equal, we just multiply by 4. Area of the sectors is 9 pi. And we had calculated and realized that the area of the square is 9. So we add the area of this composite figure is 9 pi plus 9. We are leaving it in terms of pi. If we factorize and 9 is common, we take it outside the brackets, then we have pi plus 1. That is the area of that composite figure. Find the area of the shaded region. You are given a figure like this. So again, you realize that this is a composite figure. It's not the basic shapes that we know of. We have a right angle here, and then we have a curve. So that means there is a circle somewhere. If you connect using dots, you realize that there was a square. There is a square because this is 15 kilometers and this is 15 kilometers. So there's a square, and inside that square, or from that square, a sector was carved out. So we are told to calculate the area of the shaded region. So first of all, we'll calculate the area of the square, which is 15 kilometers times 15 kilometers, and that will give us 225 square kilometers. Then we need to remove the curve here, and you realize this curve has a radius of 15 because it is the same measurement of the length of the square. Then it is a quadrant. It correctly, then you realize that we have 176.78. Then we subtract the area of the square minus the area of the sector. That will give us 23.22 kilometers square. So that is the area of this composite figure. So today we have learned about how to calculate the area of sectors and composite figures. And we realized that for you to be able to calculate the area of the sector, you need to understand the fraction of that sector, because it is normally, a sector is a fraction of a circle. And for you to be able to know the fraction of the circle, you identify the angle at the center inside that sector, you divide by 360. Then you multiply by pi r squared. For composite figures, we said a composite figure is made up of 2 or more basic shapes. And for you to be able to find the area of a composite figure, you need to identify the basic shapes, calculate their areas. You can add or subtract depending on what is required. So that is what we have learned today. Next lesson, we will learn about how to calculate the surface area of prisms and the surface area of prisms. Thank you so much.